Welcome to today's science inquiry. I'm George Wolf. Now today's inquiry is going to use just some simple water, 4 flasks, and you'll notice some red food coloring. Now let's take a look at this demonstration first. You know I'm going to ask you a question, and you know I'm going to ask you to look up some vocabulary, but first I want to amaze you with some science. So what I have here, you'll notice red on top, clear on the bottom, and a card separating them. I'm going to slide that card out with a minimum of mess, I hope, and golly gee whiz, you'll notice what's starting to happen. The red is going down into the clear. Now, while you're looking at that, let's look at this one too, because certainly that looks like that red water is heavier than the white or the clear. And after an initial slight movement of red into the clear, boy, it just doesn't seem to be doing the same thing. Well, I got a question for you, but before I ask you the question, you're going to want to look up a couple of terms. You're going to want to look up the term density, and you're going to want to look up the effect of temperature on density. Now, after you've looked that up, you can try to answer the obvious question that's going to go along with this inquiry challenge. Why did the water in this first set clearly mix up, and in the second set not mix at all? Good luck on this one. When you answered this question, did you predict that these two liquids were of different densities, and that in this case the denser one was on top and therefore sunk, and in this case the denser one was on the bottom and therefore did not rise, and of course that would be less dense? Well, if you did that, you got the right answer. Now, sometimes in science we like to say, well, if that's true, then this will be true. So let's try that. If this indeed is denser here and this is less dense, predict what will happen if I flip them over, huh? Come on, predict, predict, predict. You got it? Let's see if you got it right. Now, paper towels just in case. This is a little bit tricky, so we want to get this, and we want to take it, and we want to flip it over with a minimum of mess, and golly gee whiz, look what's happening here. The less dense, you were right, the less dense is actually rising up through there, and that helps explains this challenge. And let's go to the board together, and we'll do it in pictures too. All right, well, here's the 2 flasks, or the 4 flasks as we started out, and you'll notice that the red one is on top in both cases. But what happened here was that the red trickled down, and it came down into here, and nothing happened over here. And you know you looked up the word density, and you probably found out that density is defined as mass in a given volume. Or in other words, an equation for it is mass per unit of volume. But you know what? Sometimes that doesn't make sense. So let's do a little bit of a picture here and see if we can explain it. Let's take a look at a cold object. Now, when an object is cold, like you, what do? You kind of like get down and, you know, you're cold. Well, molecules contract. Of course, molecules are things that matter is made out of. And when molecules contract when they're cold, you get a lot of them. I will make them blue just for color's sake. So you're going to get a lot of molecules all contracted in here, which means you can squeeze a lot more molecules into there than you can when it's warm, because when it's warm, and we'll go with the red theme for warm, when it's warm the molecules spread out and they're not quite as many molecules all over the place. So think about it. Which is going to be heavier? One where they're all squinched in, or one where they're all spread out? Squinched wins. Squinched is heavier, and so what's going to happen is the heavy is going to fall into the light, cold is going to move into warm when I put those together, because cold is denser than warm. That is cool stuff. So let's summarize this. What's density? Density is the amount of mass in a given volume, or mass per unit of volume. Denser objects, number 2, will sink through less dense objects because they tend to be heavier. And any material, not like the water we used here, is always going to be more dense when it's colder because those molecules squinch together. All right, I'm George Wolf, and I want you to remember to discuss today's science challenge with your class and your teacher. And I'm going to challenge you guys again next time. Remember this, you'll never get any answers unless you ask those questions.